Hello, good morning, good afternoon, good evening, whatever time you're doing this lab. This is the companion video for the Sun's Path lab. Again, these videos are to be used for your assistance and if you can't load the app on your computer due to flash restrictions. This one's kind of complicated to manipulate, so I'll walk you through it and talk about how we're going to do it. So the first thing is the time of day. If you think I'm looking over to the side, I've got my lab on the computer right next to me. I'm actually running 2 Chromebooks right now. So I'm looking to the side. I'm not distracted by anybody. I'm just trying to read the lab. So I'm going to select the day of the year as the 21st of March, and I'm going to start the animation. So what you'll see is as the animation runs, the sun is going across the sky. So that should give you enough information. Now, if it's going too fast, you can actually slow down the animation so you can see it a little more clearly so you understand the effects. Now, the light gray line in the middle, I'm pointing at the screen again. You can't see what I'm pointing at. I'll use the cursor to do this. This light gray line here is the solar noon for that day. That will come into play later in this lab. Okay, so again, if you're using this video, you can stop it, rewind it, fast forward it, whatever you need to do to get the information that you need to get from it to answer the questions. All right, so that is part 1, time of day. All right, so time of year's got a bunch of different ways to manipulate this system here. So I'm going to stop my animation, okay? And I'm going to click reset. So now we're back to the beginning. Now, the instruction says this simulator has many ways it can be manipulated to show a variety of data. You can move the sun along its path, so it looks like this, to show different times of day. I can move it this way. Okay, I can also rotate it this way. I can rotate it up, down, and so on. So if you're just using this as a companion to figure things out while you're using the actual one, fool around with it, see what you like the best. Okay, I'm going to click reset. Anytime you start over, you can click that reset button. All right, now what we're going to do is we're going to look at a few things. All right, here is our east, north, south, and west, and so on. Underneath it is some data here. Sun's altitude, how high the sun is at any time during the path across the sky, and the azimuth. We did something earlier this year with the azimuth. It's a degree measurement of a circle with north being 0, east being 90, south being 180 degrees, and west being 270 degrees of a circle, giving us a directional measurement in angular degree based on 360 degrees in a circle. Okay, so we're going to start by looking at several different things. So first thing we're going to do is we're going to set the observer's latitude to 43 degrees. Why 43 degrees, you ask? Well, because that is our latitude in Syracuse, New York. So, whoops. 34, there we go, 43. So I've just moved that there. And we're going to start with March 21st. 21st of March. Now, we know that as the vernal equinox, or the spring equinox. All right, we're going to look at a few things here. Location of sunrise. So if I move this back here to sunrise, and I'm going to spin it around just to get a better look at it. Spin it around to sunrise. There's sunrise. Okay. Right there. Okay. At sunrise, the azimuth degrees of sunrise on March 21st is approximately 90 degrees, which is directly east. Okay. The time of sunrise, it's right here. Time of day, 6:09. 6:09. So here's our azimuth coordinate. Here's our time of day. All right. And if I move the sun along its path, I get to the middle here, that gray line, which I talked about before, at solar noon, the highest point in the sky. So if I go to solar noon, it can be approximate. I'm going to try to get it as best I can here. All right, so here are 12 noon. The sun's altitude is 47.5 degrees. 47.5 degrees. Oh, I skipped something. I'm going to go back here. Time of sunrise was approximately 6 a.m. Okay, 6 a.m. Solar noon. Altitude is 47.5 degrees. If I spin it around, I can drag the sun down here to its sunset position, and its sunset position is approximately there. Okay, it says 1808. Now that is in military time. That is 6:08. So it's approximately 6 o'clock. So the sun rises at an equinox at 6. The sun sets on an equinox at 6. Okay, so that means how many hours of daylight did we have that day? Well, that's a math question you guys can answer. All right, so we go from, that's your March 21st. Then we go to June 21st. Change this to June. Okay, and I'm going to start off on the east. So I noticed that it does not rise directly east, set directly west, just so you know. That's a question for later. All right, so here's our sunrise on June 21st. It is at 4:24. Okay, and our azimuth coordinates at sunrise is approximately 56.7 degrees, or 57 degrees, or so, 57.5 degrees. There we go, 57.5 degrees, 4:30. All right, then move it across to our solar noon time. Okay, just a little bit past that. All right, there is our sun's altitude, 70.4. And I'll bring it down to sunset. About right there. Okay, and then you can record your numbers. Okay, again, it's azimuth coordinate, time of sunrise, altitude noon sun, location of sunset, time of sunset, and hours of daylight. That's the table. Okay, so if you need to go back and review and rewind to get that information, slow it down, whatever, please do so. I'm going to go from June to September. We know that is the autumn equinox. It's got a little variation. It's the 22nd. Okay, and I'll go back to east. Go back to sunrise. I didn't bring the sun with me. There's the sun. Moving the sun back over to sunrise. Okay. Okay, so there is our sun's azimuth approximately. Back a little bit here to get the actual sunrise. You'll notice the shadow changes up here when you're at sunrise. Okay, so that's approximately 90 degrees, approximately 6 a.m. Altitude of the noon sun. Right there. Altitude of the noon sun. Come here. There we go. All right, there's your information again. Speed it up, back it up if you need to if you need me to slow down. I'm just showing you everything. You can do the time you want to do it at. And now December. Spin it around. There we go. Oh, I gotta move it up so you can see everything. There we go. Okay, spin this around. Altitude of noon sun. There we go. And sunset. There you go. So now you have all the information to figure out the data tables that you need to complete. again, if it was too fast, you didn't get it all, back it up, repeat it, and go from there. And then that should answer your questions as well. Questions are a little more difficult this time just because I want to challenge your brains. So, till next video, we're done.